Assalamu alaikum warahmatullahi wabarakatuh. So today we will discuss about another method which is known as the Newton-Raphson method. Okay, Newton-Raphson method. So this is one of the very important method, and it is one of the best known method. It is one of the best known method for finding the solution to linear and transcendental equation. So finding the root of linear and non-linear algebraic and transcendental equations. Okay, so this is used to find the root of the algebraic and transcendental root of algebraic and transcendental equation. And this method, if you know the function, if the function is f of x and you want to find the root of this function, that means you have to find the root of this function. That is the question actually. So how to find the root of this function? Find the root of this function. Then you need one more thing. You need to find the derivative also. Derivative, that means f dash of x. What is f dash of x? You need to know what is f dash of x, or you need to calculate it. It is d by dx of f of x. Okay, so you need to know the f dash of x. Without f dash of x you cannot proceed. So what is the procedure for a Newton-Raphson method? Okay, and the procedure is like, if you know a function, suppose this is your function f of x, okay, and this is x, and you want to find the root of this function. Now what is the procedure? First you have an initial point. Let's say you have an initial point x1. You have an initial point x1 and you know what is the value. You can calculate it, f of x1. You can calculate what is f of x1. You know it, okay, and this is f of x1. That's what it is giving, f of x1. Okay, I am just marking here itself. Now what you will do for finding the root, actually you will first find the slope of the tangent passing through this x1. So the slope of this tangent, you will draw a tangent here, and you know that this tangent is meeting here at this point x2. Okay, and now the width of this point is nothing but x1 minus x2, or we can say delta x. And what is your delta y? Your delta y, this point actually y equal to 0, and at this point your y is equal to f of x1. So delta y is nothing but f of x1 minus 0. Now what is the slope of this tangent? The slope of this tangent is nothing but delta y by delta x. Okay, that is nothing but f of x1 minus 0 divided by x1 minus x2. So this is the slope of the tangent. So the slope of the tangent is having another definition also. It is nothing but the derivative. That is nothing but f dash of x. So we got an equation that f dash of x is equal to f dash of x, or means we are talking about the point x1. We are talking about the point x1. So it is f dash of x1. So f dash of x1 is nothing but f of x1 minus 0 divided by x1 minus x2. So this is possible only if you are very close to the solution. So where is your original solution? I will just write the original solution now. Your original actual solution is alpha, such that your f of alpha is equal to 0. So this is your original solution, actual solution. Now you see I got a point x2. So in the second iteration, so this is an iterative procedure. So this is Newton-Raphson method, and this is an iterative procedure. Now you know what is x2. So from this x2 you will find f of x2. Okay, you will find what is f of x2, and you will draw another line here. This is slope which is here. You will draw another line. Now you see it is meeting at some point. Let's say this point is x3, and you know what is here, f of x3. So you got another point. That means that in each iteration, you were here first, you move to x2, from x2 you are moving to x3, and from x3 you are moving to alpha, like this. That means you are moving towards the solution. You are moving towards the solution in each iteration. So I will make it more clear with a big picture, that is better. So you know how to calculate now. So you see here f dash of x. So before that, before showing the picture, I will show you how you can calculate your x2 from this. Now you know what is the equation for f dash of x1. So f dash of x1 is equal to f of x1 minus 0, that means f of x1 divided by x1 minus x2. So I can write my x2 minus, I can write my x1 minus x2 as f of x1 divided by f dash of x1. Okay. Now I want to find the new point. So my new point is this one. This is my new point. Okay. So I can write my minus x2 is equal to minus x1 plus f of x1 divided by f dash of x1. So I multiply with minus 1 on both sides. So x2 is equal to x1 minus f of x1 divided by f dash of x1. So this is how you are proceeding. Or I can say in another way, I can, if I have an initial solution, if I have initial point or a solution x0, then I can calculate my x1 from x0 as x0 minus f of x0 divided by f dash of x0, right? Now from this I will find my x2 as x1. If I know x2, from x1 I will find x2. Okay, I will find x2 as x1 minus f of x1 divided by f dash of x1. Then from x2 I will find my x3 as x2 minus f dash, not f dash, f of x2 divided by f dash of x2. So this will continue. So I can write my xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Okay, this is my general formula in Newton-Raphson method. That means as you progress, your xn plus 1 or your xn plus 2, like this it will go. So it will move towards the actual solution. So I will again draw how you are getting the solution now. So this is your f of x, you know, this is your x1, or you can say I will start with x0. Now you know what is f of x0. So I will just draw a line here now, and I will find the slope, and according to that I will find my, so I got some point here. This is my x2, x1, and from x1 I can find my f of x1. Then I will draw again another curve here. This is moving here. See, now I got x2, and from x2 I will find my f of x2. Next I will move towards this. Again I will draw a line. So you see I am moving towards the solution. And where is my original solution? My original solution, actual root is here, alpha, not infinity, it is alpha. Okay, so my actual root is alpha. So I am moving towards the alpha. So I can say that I am moving towards the alpha. Now you see what is the error. This is your alpha. I can say this point is alpha. Okay, this point is alpha. I will mark it here itself. So at the 0th iteration, initial point, what is the error actually? The error at 0th iteration was, how much was the error? Now the point is x0 minus, and actual point is alpha, That is the error. In the first iteration, you have x1 and x1 minus alpha was the error. Then in the third iteration or the second iteration, you have x2 minus alpha. Then in the third iteration, this is the error. I will just mark here all these are error. Okay, so I will just say this is the 0th error, this is the first iteration error, this is the second iteration error, then x3 minus alpha is the third iteration error. So I can say that the error epsilon 0 is equal to x0 minus alpha. Then the error, if you take the magnitude of the error, you can say like this. Okay, then the error, this is nothing but x1 minus alpha, and this is nothing but x2 minus alpha. So the 0th iteration, this is the first iteration, this is the second iteration, this is the third iteration, it will get, it is x3 minus alpha. So what is happening here? You can notice that your epsilon 0 is very high. Then what is happening? Your solution is actually moving towards, your iterative solutions are moving towards the actual solution. So what is happening? The error is decreasing. So epsilon alpha, I can say that my epsilon 3 is less than my epsilon 2. It is converging. That means my epsilon 2 is less than epsilon 1. It is less than epsilon 0. So like this it is going on. Okay. So this is nothing but happening in the Newton-Raphson method. So we will talk about something more about the convergence of this algorithm. So I told you, so I will talk about, so you can see that this error is decreasing in each iteration. So we can say that the algorithm or the method is converging. So we will talk about what is this phenomenon, convergence of this algorithm, and what are the conditions needed for this convergence. So the convergence of Newton-Raphson method. Okay, you know that xn plus 1 is equal to xn minus f of xn divided by f dash of xn, right? This formula we have already seen, and we will call this as phi of n, phi of xn. Okay, I am just calling it as a function. So I can say that my phi of x is equal to x minus, in general, f of x divided by f dash of x. This is the form. Now if an algorithm, so this is my phi of x. Now a method converges if its derivative decreases. That means its derivative is less than 0. If derivative is greater than 0, that means the function is increasing. If derivative is less than 0, that function is decreasing. So we can say that if phi dash of x magnitude is less than 1, then it is converging. Okay, then the method converges. Okay, so the method is converging only if its derivative is less than 0. Okay, now we will check whether it is less than 0. Now what is the condition for that? So we know that phi of x is equal to x minus f of x. Okay, f of x divided by f dash of x. So phi dash of x, I will get it as, first I will take the derivative with respect to x, it is 1 minus, now the denominator, you know what is u, we roll in differentiation, so f dash of x the whole square. Okay, then I will take this the derivative of the first term, so I will take this f dash of x here, and then f dash of x. Okay, then it will become f dash of x the whole square. So f dash of x the whole square minus, you will get this is f of x into the derivative of f dash of x is f double dash of x, the second derivative. So this is what. So if you simplify this, you will get it as f of x into f dash double dash of x divided by f dash of x, okay, the whole square. And if I take the magnitude of this, then can be written as, I can just take the magnitude of this, and this should be less than 1. That means that this should be less than 1 for convergence. So for convergence, that means that your f of x into f double dash of x, if you take this at a particular point, if is less, should be less than, I will take this guy here, then if I multiply with 1, then it become f dash of x the whole square. So the method will converge only if this condition is satisfied. Okay, the method will converge only if this condition is satisfied. Otherwise the method will not converge. So at a given point, for example, you have a function, for example, you are at the point xn, then you know what is f of xn, and you will also calculate the slope of this. And what is the slope? It is nothing but f dash of xn, okay, and you will also calculate f double dash of xn, right? Okay, now what you will do, you will check, you will multiply this f of xn with what? F double dash of xn, then you will take the magnitude of this. If this is less than f dash of xn, then you will take the magnitude of this square, then you will take the magnitude of this. If this is less than this, then if this condition is satisfied, if this condition is satisfied, then the algorithm or the method converges. Okay, so that is the idea of convergence. Now how fast it is converging, you see this is xn, and from this I will calculate here xn plus 1, and from this xn plus 1 I will again proceed further. This is, you see, this is xn, then I will proceed further and I will get this point as xn plus 2. Like this I will be proceeding, but how fast it is moving towards the solution, that's what now we are going to analyze. Okay, so the rate of convergence of Newton-Raphson method. Okay, now I will just first draw the figure. You know this, this is your xn, and at xn what you will do, you will find f of xn, then you will also draw a curve, and you will find x of n plus 1, and from this you will find x of n plus 1, f of x of n plus 1. Okay, now what you will do, you will find the next point. Okay, you will find the next point. Now like this you will be proceeding, then this is nothing but x of n plus 2. Okay, like this we will be proceeding. So I can write my actual solution is somewhere here. My actual solution is here. I can show it by a different color. This is my actual solution, which is alpha. So xi or xn, let's say xn, my xn is very far away from the alpha. This much distance is there. So what is the error? My error is equal to xn. Okay, alpha my error is equal to, I can say that my error is equal to, what was the definition for the error I have used here? My error is equal to x0 minus alpha. So my error like this, xn minus alpha. So my error I can write like this, xn minus alpha. Okay, so I can write my xn from this equation as xn is equal to my error my actual solution alpha plus epsilon n. Similarly, I can write xn plus 1 is equal to alpha plus epsilon, or error is at the n plus 1th iteration is epsilon n plus 1. But note that epsilon n plus 1 is always less than epsilon n, so that your new solution is very close to your actual root. Okay, so you know that this is our formula. Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Now I will just substitute here this with our actual value which is related to the error. So epsilon, this is nothing but alpha plus epsilon of n plus 1, and this I will just replace with alpha plus x of n. Okay, this is minus f of x of n is nothing but alpha plus x of alpha plus not like this epsilon n. I have made a mistake. Yes, this is correct. Actually, this is correct. So it's plus epsilon n, and this is epsilon n divided by f dash of alpha plus epsilon of n. Okay, epsilon n. Now I will use this, I will simplify this, okay, by using the Taylor series expansion. Now you know that there is alpha here on the both sides, so I will cut this alpha and this alpha. So I can write epsilon of n plus 1 is equal to epsilon of n minus f of alpha plus epsilon of n divided by f dash of alpha plus epsilon of n. Okay, now for this function, actually I will be writing epsilon of n plus 1 is equal to epsilon of n minus, I will be just writing the Taylor series expansion for this. This is the Taylor series expansion. You might have studied this in your first year engineering mathematics. So this is nothing but f of alpha plus epsilon I into f dash of alpha plus epsilon, not epsilon I, epsilon n square by 2 into f double dash of alpha. Okay, f double dash of alpha plus so on. Okay, it is an infinite series. So f double dash, so this become, I will just expand this f dash of alpha as f dash of alpha plus epsilon n into f double dash of alpha plus and so on. Okay, so this will continue. This is a series anyway. So but you know that f of alpha, because f of alpha is nothing but the root, actually alpha is the root, so f of alpha is nothing but, it is coming here, it is equal to 0. Okay, so f of alpha is equal to 0. So you can actually write epsilon of n plus 1 is equal to epsilon of n minus epsilon of n into f dash of alpha. Just simplifying this, epsilon n square by 2 into f double dash of alpha plus so on, and this is this divided by f dash of alpha plus epsilon n into f double dash of alpha plus so on. Okay, so it will go like this. Okay, now we will simplify it again. This is equal to epsilon of n minus, I will just take this guy epsilon of n as outside, so into f dash of alpha plus epsilon of n by 2 into f double dash of alpha plus so on. There are a lot of terms, divided by f dash of alpha plus epsilon n into f double dash of alpha. Just this is a simplification, so you will get it as half of epsilon n into f double dash of alpha divided by f dash of alpha plus epsilon n into f double dash of alpha plus so on. Now I am going to simplify this equation in another way. Okay, you can cross check it, I'm going to simplify this equation. You can cross check it. This will become epsilon of n plus 1 is equal to half of epsilon I square f double dash of alpha, not I, it's n, divided by f dash of alpha into 1 plus epsilon of n into f double dash of alpha divided by f dash of alpha. Okay, and you know that this term is usually very small because you have f dash and f double dash and epsilon n. So this ratio will be very small, so I will be neglecting it small, so I can neglect it, so that this will become half of f double dash of alpha into epsilon n square divided by f dash of alpha. So this is your epsilon n plus 1. So I will write epsilon n plus 1 is equal to half of f double dash of alpha divided by f dash of alpha, okay, into epsilon n square, or this is nothing but this is some number, some constant you can say, into epsilon n square. So epsilon n plus 1. So this is what you are getting. That means that the error in the n plus 1th iteration, error in the n plus 1th iteration is depending on the error in the nth iteration. And how it is depending? It is the square of is depending on the square of the error. Okay, it is depending on the square of the error in the nth iteration, so that it is a second degree. That means you can say that epsilon n plus 1 is equal to some constant into epsilon n square. So you see here, error in the n plus 1th iteration, this is the error in the n plus 1th iteration, is depending on the error in the nth iteration, and this is depending on the square of the error. So we will call it is the second degree convergence, second degree convergence, or we can say that it is quadratic convergence. Okay, so Newton-Raphson method is having quadratic convergence. Okay, so this little bit fast convergence, you will get the solution very fast. That means because it is depending upon the square of the error, so it is very fast. Okay, so that is how you are getting this is known as the quadratic convergence, because the error on the current iteration is depending upon the square of the error in the previous iteration. Now we will see a problem. After that we will wind up and we will continue with another problem in the next class. Okay, example problem. Okay, use the Newton-Raphson method to find the real root near 2. So near 2. So the initial value is given of the equation x raised to 4 minus 11x plus 8. Okay, accurate to 5 decimal places. Okay, so we will find the solution. Now we know that what is f of x. F of x is equal to x power 4 minus 11x plus 8, and f dash x means you take the derivative, it means 4 into x cube minus 11, right? So this is, now x naught is given, which is 2 from the question. Okay, initial solution is given, so you can find your x1. Now you can find your x1 is equal to x naught minus f of x naught divided by f dash of x naught. Okay, so this is what the method. Okay, this is what the methods tells you. So x naught is 2 minus then x naught is 2, then f of x naught. What is f of x naught? 2 power 4 minus 11 into 2 plus 8 divided by 4 into 2 cube minus 11. This is just substitute 2 there. So you will get this answer as 2 minus, okay, 2 by 21, sorry, 2 by 21, you will get it. This is nothing but 1.90476. So you got your x1. Now you know what is x1. x1 is equal to 1.90476. Now we will see what is x2. What is x2? x2 is equal to x1 minus f of x1 divided by f dash of x1. So this is nothing but 1.90472 minus, what is f of x1? It is nothing but just substitute in the equation 1.90472 the whole power 4, right? Same equation, right? Yeah, 4 minus 11 into 1.90472 plus 8. So this is the first part divided by the f dash. That means it is 4 into 1.90472 the whole cube. Okay, because you see it is 4x cube, then minus 11. So you will get it 472. You will get this. Okay, so you will get this as you will get it as 1.89209. Okay, you got it. What is x2? Now you will find what is x3. x3 is equal to x2 minus f of x2 divided by f dash of x2, which is equal to 1.89209 minus, you just substitute in the function f of x, just substitute f of x2. So that is nothing but you substitute 1.89209 whole power 4 minus 11 into 1.89209 plus 8. So that is your f of x divided by f dash of x. It is nothing but 4 into x cube. That means 4 into 1.89209 the whole cube minus 11. So you will get this as 1.89188. So that is the, so you see here the first solution, x2, if you compare this 2 decimal place is okay, but third decimal place is not okay. We need the answer for 5 decimal place, I think. So anyway, I will just rewrite the question for 3 decimal places. So for 3 decimal places, 5 decimal means you have to do more iterations. Okay, now we have to find now x4. x4 is equal to x3 minus f of x3 divided by f dash of x3, which is equal to, what is our x3? We have just found it. I think we have to, yeah, we have just found it, 1.89188 minus 1.89188 the whole raised to 4 minus 11 multiplied with 1.89188 minus plus 8 divided by, okay, sorry, I will just use in the next there is no space here, that's why. So this is equal to, what is x3? It is 1.89188 minus, then f of x3 means 1.89188 the whole power 4 minus 11 into 1.89188 plus 8 divided by 4x cube. That means 4 into 1.89188 the whole cube minus 11. So you will get this answer as 1.8188. You see here we are getting the answer as here actually it is 1.89889188. Again we are getting 1.8 9 anyway, we 89188, so it is converged. So you know that now x3 is equal to x4, and same up to 5 decimal place itself. Okay, so you can have in the question I have given you 3 decimal place, but it is accurate up to 5 decimal place. So the solution is 1.89. What is solution? Solution is nothing but the root 1.89188. Okay, that is the solution. I hope this is clear to you.